our material philosophy is something that I've named high-tech naturalism, which is we're really looking at returning to the biocycle and the bioeconomy. So looking at the processes of nature and thinking about how we can actually augment them. So where are there places of abundance, like waste, agricultural waste, carbon transformation, right? And then how do we use the highest level science and technology, the newest and most unique processes to actually augment the natural systems?
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. And now, let's get on to the episode. Hey everyone, our special guest for today's episode is Dr. Amanda Parks, a fashion scientist with over 15 years of experience in fashion innovation, sustainability, wearable technology, interaction design, and smart materials. She is currently the Chief Innovation Officer at Pangaya, which is a material science brand with a mission to build a sustainable future in lifestyle products. She's been recognized as one of Ali Watch's 10 most influential people in fashion technology. And I was reading through her LinkedIn profile, and she's made several other lists that would take a while to get through. So just needless to say, we're super excited to bring such an influential figure onto our show. So thank you so much for joining us today, Amanda.
Yeah, thanks for having me. It's nice to be here. Glad you guys are working on this podcast. It's a great topic.
Thanks.
I'm biased, of course.
Us too, yeah.
Yeah, like Pingais said, you've had quite the diverse set of experiences thus far in your career and made lots of lists, including a dual degree in mechanical engineering and art history at Stanford, co-founder of a microalgae biofuels company, assistant professor at Columbia in the Department of Architecture, and now you're the chief innovation officer at Pangaya. We would just love to understand what ultimately led you to discovering the passion for utilizing sustainable materials within the fashion industry.
Yeah, you've definitely done your research on me. Thanks. But yeah, so I know my career path, did not have a straight line trajectory, but it makes sense looking backwards, right? Hindsight is 2020. But, I kind of came into the world of engineering very much with a focus and a kind of an appreciation for the arts and aesthetics. So I was kind of one of those kids who was like, I'm good at math and physics, but I loved fashion as a kid, which, now is more common, but I think, back then I was lucky to get support and no one told me that was too strange. After college, I was working on things like exhibit design for science museums, right? So informal science education and kind of understanding, getting this appreciation for how you can utilize methodologies for teaching to empower people kind of to act in the world. So, and then when I went back to MIT for my PhD, kind of that motivation was I was sort of frustrated with the tools that we could build experiences with. And this was, the digital revolution that, was arising. This is, 15 years ago. And we were starting to look more deeply at this interaction between the physical and the digital world. And this is really where this idea of thinking about how digital technology can start to influence and augment physical materials and behaviors. And that was really the focus of my PhD. So, and I ended up doing a lot of work on soft materials. So textiles were a huge one, but as you know, this kind of, it's much harder to control things that are soft in the physical world with the rigidity of ones and zeros of digital tech. So that's kind of where I started kind of work. I got into fashion kind of through the back end, where it was like thinking about soft materials, understanding how the body works. So also thinking about wearable technology, and you're trying to sense systems of the body with, again, this rigidity of ones and zeros, but biological systems are so fluid and are much harder to try to kind of understand and sort of, re-engineer, or sort of, that a whole idea of trying to understand our DNA from an engineering perspective and how we behave. So that kind of led me, and then my whole exploration into algae came from understanding how we can use really kind of optimizing photosynthesis around growth and using the tools of digital tech in all the biological processes. But yeah, the fashion thing came partly from my deeper understanding around soft materials. And then I just loved literally the expression, the expressivity of fashion. It's kind of, the art of the streets. And I loved it as a language of personal expression and just color, and what it kind of meant to me personally. It was just so much fun. And it also was, an interesting differentiator for me as an engineer. I think there's sort of been a time in my life where I'm the most stylish person in an engineering context, and then I'm the nerdiest person in a fashion context. And that's sort of where I end up sitting quite happily. So yeah.
That's so cool. So this term innovation, it's very important, but it's also just like a broad term. So I was just wondering, what exactly does your role entail as a chief innovation officer?
Yeah. So I think if we were to drill down, what I mostly focus on, you could call me the chief science officer, but I keep the role as innovation because we actually are spreading beyond just the physical science material. So thinking about how things like digital technologies and having digital platform kind of interrelated to material transparency sits. So so it's a way to kind of keep it open to say, look, I'm guiding how our brand treats kind of new technologies, new innovations, science being the key one. But yeah, so my role involves kind of guiding our scientific strategy. So thinking about where do we want to be? Well, what do we want to make our material, our garments out of now? But then also looking at the future of the industry 2, 5, even 10 years out. And the way that Pangaea works, we function more like a tech company in the sense that we're looking to actually design and change our own industry internally. So this idea of internal R&D, one of the things that I had worked on projects with Google and Intel and big brands, and their focus is looking at how do they want to change their industry, like through the creation of whatever that they wanted to say, this is how we want our industry to be in 10 years. This is how we're going to get there. And in fashion, there wasn't a whole lot of internal R&D. They were very much dependent on materials that were coming from other places, from different forms of research, and so we decided to kind of think of. I was surprised by that, and I said, this is actually an opportunity right inside of this space. So that's kind of my role, and then guiding our team across also what are our research pillars. So what are the things that we care about as a brand, and also expanding. We're not just looking at innovation for innovation's sake, but very much in the context of sustainability, environmental impact, everything that goes into looking more broadly at how the clothing is made, so the social issues around it. So kind of there's a broader perspective on what we're doing inside of the innovation focus.
So you talk about scientific almost storytelling a lot, and when it comes to sustainability and sustainable materials especially, the things that make it sustainable are very technical and not very easy for most people to understand. How does Pangaea try to tackle that issue? And especially with your role as Chief Innovation Officer, do you try to help shape the story around sustainable materials?
Yeah, absolutely. And that you've probably caught on if you've been inside of our website or social media, that's a big part of what we do. And we see it as the idea of scientific communication and making things accessible to people is an important part of our brand. And I think so part of that for me comes from, again, starting my career in science museums and informal science education, and understanding how kind of making things accessible is a powerful tool to empower people to ask questions even beyond what you're telling them. So this idea of science isn't scary. It isn't, it doesn't just have to be about hard math and equations. There's multiple ways to learn it. And one of the things that I think we're pretty lucky with in Pangaea is that there's incredibly beautiful images in nature that we can tap into as sort of to draw people in. And then fashion, of course, is an aesthetic medium. So we have a lot of visual imagery, which I think can be really powerful to at least draw people in. And then it's about working hard and just putting in the time and energy to try to clearly explain, break down terminologies. Our goal is to, we will use the hard words, but we will explain them in common language. And I think that in itself is, scientific writing is its own kind of skill set, because, as you're trained as scientific engineers. It's sort of like when you're writing publications, the more technical, the better, right? You sound smarter, or you're trying to get at the real essence. So it's sort of in some ways the alternative of how can I make this as simple and clear as possible and just not have it be intimidating. So part of that is really about having, we have an impact team, we have an editing team, we have an incredible marketing team and people who have experiences in the spaces, and then putting in the time and effort as a brand. So I think, in order to get to the, on our clothing, we have this text block, which is our identifying kind of branding, right? And it's useful information about what the clothing is made of and how it's made. And the amount of time and energy that goes into what these two sentences are is extreme. It might start at a page, and then how are we going to get it down, and then tuning every word so that it's understandable and it's correct and all of that. So that's just kind of what we see as part of our process and have committed to it. So.
I mean, I'm definitely seeing just a lot of similarities between your mission and kind of like what we want to do with this podcast too, is just be able to explain these like technical concepts to anyone that's interested in the field in a way that's easy to understand. So it's really
and fashion is a great entree because there's not a single person in the world that doesn't experience textiles. That's maybe not true of something like carbon nanotubes or other more complicated scientific things, right? But this idea of saying you have this in your home. Do you know how it's made? Do you know what it's made of? Do you know the possibilities? So you have a starting point to jump off from. That fashion's like super easily accessible. So that's also one of the reasons I love it. And when I was teaching more like wearable tech, it's also a great way to especially bring in like teenage girls, like, you can make your, an extension of your fashion, right, through learning electronics. Like, what better thing is that? For me, it would have been like, that would have been an absolute dream as a teenager. Yeah.
So I guess then my follow-up question is, how do you get people that might not have like the STEM background or the true STEM interests interested in, what is this made of and why is it important, rather than just purely the aesthetics of it all?
No, sure. Well, I think there's a couple different angles. And one is, I think, and people's interest in climate change and recognizing how serious and crucial this is, right? So when you start to dig in, this is also a good entree point where people, you start thinking about, okay, well, we all know about ocean plastic, and, there are these things that are appearing in the media. We know how important they are. And how do you kind of get at the way to address it in the commonality of your lifestyle? So your food, your clothing, your home, right? These are all things that people can, because it's not like you're reading a crazy, scary report about, carbon, and, there's a lot of very complicated ways to try to think about and understand climate change, but it's like this, it gives an accessible place for people to start from. So of course, people's interest in climate change is growing happily, thankfully, and especially with young people kind of trying to understand how they can make a difference. So that I think is maybe one of an easy entree point for a lot of our consumers, and their motivation to kind of, you put their money where their mouth is or where their values are. So buy around your values. And I also think it's interesting what we're seeing now in kind of Gen Z and Gen Alpha is they like this idea of fast fashion is slowly dying. I really believe that, because we had this kind of surge of, oh yeah, I can have so many new things for so cheap and everything. But now there's a kind of reversal where vintage is cool again, reuse schemes. And this is all kind of from the digital revolution place too, where like Depop and all these rental services. So things that you can have, fashion has as an experience. You don't have to, you can experience fashion and use it and have fun without it having to be entirely about consuming and buying it. And that's a kind of a mental shift that I think we can also play into with our brand. Because maybe, for example, our clothing sits at kind of a moderate price point in the context of fast fashion to luxury, but it could be a little more expensive for younger people. But this idea that, okay, there's a value in owning good quality basics that you love, and then having, rental services for fun party dresses or whatever it is. So this kind of shift in the consumption models is also something like that we think makes it part of an accessible conversation for a broader audience.
Cool. All right. So I guess before we dive into maybe the material science behind some of Pangaia's really cool technologies, you've talked about the goals of Pangaea a little bit, but I just wanted to get into, how it differentiates itself from other consumer brands? Because now I'm seeing some other, whether it's in the fashion industry or not, just more companies with a strong focus on sustainability in one way or another.
Yeah, so I think the first way that we differentiate ourselves is that we are kind of R&D material science led. So I like to use the phrase that we are, we're a material science company that manifests as a fashion brand. So that's how you know us, but really what's going on internally is this, we're guided and driven by a different thing. And so that in itself, just from our founding team and all the structure of the company, like we have an entire impact team, an entire R&D team, we own laboratories, this kind of stuff, right? It's just that the whole structuring and build up of the company is different. Whereas for other fashion brands, and especially this is hard for large brands that have been around for a while, they're having to adjust their processes and add things in, right? As opposed to this was our kind of founding strategy. And then, our material philosophy is something that I've named high-tech naturalism, which is where we're really looking at returning to the biocycle and the bioeconomy. So looking at the processes of nature and thinking about how we can actually augment them. So where are there places of abundance, like waste, agricultural waste, carbon transformation, right? And then how do we use the highest level, science and technology, the newest and most unique processes to actually augment the natural systems. So for example, flower down, which I think you know about, is our solution is an alternative to traditional animal down, but it also has no synthetics. So having no petrochemicals in any of our products is a huge research goal of ours. And so this combines a particular kind of waste wildflower that had been sort of studied by biologists and identified, and it's wild picked. It's not actually grown in farming. So there's not a lot of environmental impact on that. But then we augment the properties of this wildflower with cellulosic aerogel, which is one of the most advanced materials on earth, lightest, et cetera, and a biopolymer that's also compostable. And so together these technologies, which are both super advanced and sustainable, which that's one of our principles, where sustainability and technology are not at odds with each other. We should be using science to make things more sustainable. And then combining that, we can augment the thermal properties and the durability properties and all of that of the flower itself. So that's kind of an example of what we're going after in terms of solutions. And so it's, a lot of things about how do we have, non-toxic chemical processes. There's a lot of secret things in fashion, or things that are that you're not aware of. You could have an organic cotton t-shirt, but it could be treated with some kind of toxic chemical as part of its pre-dyeing, and you'd never know. So that's the things with the, labeling can be misleading. So we're trying to have just like full transparency on all of our processes and look holistically. So I think, as opposed to the greenwashing that does happen in the industry, some of it's maybe on purpose, but I actually think that a lot of it is non-intentional. Like the brands are trying to do good and to have the right, to do the right thing, but it's very confusing in terms of what are all the processes that are happening, getting the data, getting the information, and that takes a lot of time, energy, and expertise. And so I think some of the brands are kind of jumping on, oh, this is an easily accessible, sustainable thing to do, but not understanding maybe the complexity of everything about the processes in the back end. So.
Yeah, you gave a great explanation of flower down. And just for our listeners who don't know, the benefit of adding all these different materials is that now you can make it without having to use animal feathers or petrochemicals. Exactly. And so we would really love for you to go more in depth in how you're able to find the process in these materials that work to make an entirely new process for something we've already had.
Yeah, and part of this goes into really, at Pangaea, we do have a scientific team internally, but we also recognize that we are not going to be the world experts on all of these materials. And collaboration is at the key of what we do. And so finding the most advanced scientists in a particular area, and then working with them across some kind of product is really key. And so with flower down, that the early stages of research, that was over 10 years ago before we were even a brand. And I, before we founded, I had spent a couple of years basically traveling the world, going to labs and universities and startups and kind of assessing all the most sustainable technologies out there. And I think looking at what is happening in labs that is incredibly promising, but maybe they haven't figured out how to commercialize it yet. There's also this mismatch often of, oh, you guys are in university, this professor types are not necessarily the best CEOs, right? And it's not, they just aren't motivated in the same way to be potentially starting the company. They want to do their research, they want to do the breakthroughs. And so how do we form a different kind of structure to help those get commercialized and move into the real material supply chain much more quickly than going through, massive grant processes, or, just the whole academic structure is not set up to kind of get things quickly to market. So how can we be that partner? And yeah, so that's kind of where Flower Down started. It was with somebody who was a university researcher and had been working on, really optimizing different thermal properties and looking at natural materials around this. And he had, worked on this, an aerogel that was not silicone based. It was cellulosic, and so it could be compostable. And so, yeah, so he had kind of the early workings of this. We hooked up, we started to talk about how it could be, what are the properties of down that need to be in the market? What is this missing? How would it go into manufacturing? The initial kind of research phase, while there can be a breakthrough in him recognizing what this wildflower could do, that's about 10%, and then there's the other 90% of all of the small things you have to, not small things, but the different kind of research breakthroughs in terms of the building it up as a product and commercialization and manufacturing and all of that. So that's kind of how this happened. You naturally connect with a scientist who has either an idea or a prototype version of something, and then talk about how you can come together to turn it into product. Because as you can imagine, it's also so many different skill sets. So, somebody who's an expert in, botanical, biology around plant biology is not the same person who is going to work on the machine that needs to mix and fill down for factories for jackets, right? Those are totally different skill sets. So you have to get other people involved along the chain of the development.
Yeah. So I'm seeing the importance of like building relationships with people of other expertises, right? So I was just wondering, can you maybe give some advice or just share your experiences? Like, you found this person, right, who has this unique innovation, but there's so many professors out there, there's so many researchers out there. How did you find, I guess, like the best fit,
I used to joke around that my job is actually in scientific diplomacy. So just being able to kind of have the conversations and build the relationships and also speak the multiple languages, like science and fashion, they might as well be, French and Greek, right? So it's the people in them and the kind of their whole context. So yeah, I think it is about relationship building in a more traditional way. And then also I think it's really important that what I find to be most useful is that I do have a relatively broad scientific and engineering background. So I've studied things like mechanical engineering, understanding factory processes, but also the elements of biology and understanding synthetic biology. So I can you can piece together why something would or wouldn't work from here's a breakthrough in the biology, but is it ever going to be manufacturable? And so just kind of having that lens to kind of work through ideas has been, I think, maybe one of the best things to help us move those relationships forward and know what to focus on, right? So there's the element of like, you want the right scientists and engineering team, but you also need to kind of have a deeper understanding of how to move it across the barrier and where the market wants to be. So I think there's no like secret, there's no secret process. It's just that idea of building the relationships, speaking everybody's language and having a kind of broader understanding, both broad and deep understanding of what needs to happen. So you just got to get people to trust you up and down the process.
And was this like a natural connection, or like was there research that came into play before finally connecting?
No, well, so before Pangaea, the Pangaea founding team, we were all involved in a fund called the Future Tech Lab, where we were investing in new material innovations, most specifically focused on textiles, but in general, kind of looking at the future of sustainable materials. And this is about 8 years ago when this kind of investment wasn't as common. There's more money going into that, which is great. There's more money going into that that area, but it's a harder space because it's higher risk. It's probably a longer return on investment, et cetera. But you can also have world-changing technologies, right? So there's a high risk, high reward type of thing, and also it's obviously what we need for climate change. We don't need any more silly apps. Well, not silly, but you know what I mean. Like Silicon Valley needs to be putting money into things that are actually going to have lasting benefit for the world. So we were kind of going after that. So a lot of these relationships came through my research and scoping and due diligence there, and then also going back to my entire network from Stanford and MIT and everything that I had done in those spaces. There's nothing better than those long-term relationships to get people to trust you. Like, for example, one of the technologies that we brought out very early was something called air ink, which is basically a black ink that comes from you literally taking pollution particulate, so from factory processes, so the black soot, and then cleaning it and transforming it into a usable, printable ink. So for like this, right? And yeah, so that was developed by a friend from MIT that I'd known for a while, and he had gone back to India, and he's like, I have all the hookups on all the pollution creating factories in India, and then he started collecting in his crazy device, and I'd been through his crazy early research process in the lab, and he knew that he could trust me, and he knew that I understood the fashion industry, and I'm kind of like that conduit for anybody in these, in spheres like MIT, but Amanda, anybody know anybody in fashion? Amanda, so you kind of get that connection there. But we were able to help him with a lot of tricky things around regulation and getting it into Europe, and he just trusted me that I could make this happen, and we did. So yeah.
Awesome. Yeah, cool. I guess we could probably go on and on about Flower Down, but there's other unique innovations to talk about. And so we also heard that Pangaea creates fibers made from banana weave, where you're essentially taking waste from the food industry and converting it into a clothing product, if I understand correctly. Yep. So what exactly makes this banana weave a feasible raw material for the clothing industry, and how challenging was that process of converting food waste into something that we wear?
Yeah, so agricultural waste is a big focus of ours because it's obviously massive form of waste sitting out there. We're always going to need to grow food, and so we've been looking at all of the kind of the other parts of the plants that are not the fruit or not whatever you harvest, and this has definitely been taking off through multiple different kind of companies and research. It's not just us. We're looking at expanding basically biodiversity. This is where it's coming from, this bigger place of saying, cotton is an amazing fiber, right? That but the thing is that it's been industrialized over hundreds of years, and now we've over-industrialized it to kind of turn it into like a monocrop, and with many high concentration of pesticides in order to get it to grow. And so what we're looking at is, how do we go back to regenerative agricultural systems where plants grow together better and they supply each other's nutrients? There's the whole kind of earth balance of growing things together. And so the more kind of diverse inputs we can have, because people say, are you trying to invent the next cotton? And I say, absolutely not. We're trying to have an entire range of input. So the diversification of the input stream of fibers is what will allow us to kind of mimic the natural systems of the earth. And that will be better in the long run. So we're not trying to ever overproduce anything again. So there's lots of different fibers out there that can be, lots of different plants out there that can be turned into fibers. It's just that cotton has a couple hundred years of optimization on the other ones, right? So, and there's a reason why it is still good, and we still are going to be using it somewhat, but different plants have different fiber qualities that we can start to turn into things. And so this is just about putting in the time to figure out the supply chain and the optimization. We understand the kind of basics of how you can turn plants into fibers, but everything has its own nuance. And, so we worked with a partner on the banana. We also that with seaweed, we have, there's pineapple, there's nettle, our new nettle denim. That was a really interesting breakdown. That's not a food, but it grows as a weed. So with anything that grows as a weed and can be kind of wild harvested in a responsible way is of course of huge value, because there's not even any input in terms of land and water and all, all of that in terms of the impact. So for example, like nettle is an incredible plant and fiber potential. It's super, super strong, like even stronger, like 10 times stronger than hemp. It's very kind of harsh. It's been hard. So a lot of the ways that people worked on it was through chemical softening, which is that negates, its sustainability. So we're working with a collective that was harvesting it and then using high-end denim processes that were sustainable. We're able to soften it to a level to use it as a strength and then blend it with cotton, right? So then there's a softness there too. So it's all about how do all these different fibers work together to give us different qualities. So we can use the rigidity of something and the softness of something else to come together into different kinds of blends. So really it's about this experimentation. There's going to be no single perfect fiber. And we're going to just try to start doing, we have this kind of matrix of the, blends. And so it's all about the qualities and, everything of the engineering around it. And then the hand fill. And then of course the cost of things and how do we switch up that supply chain? Because of course, everything starts expensive if it's not readily available. So that's just, yeah.
And I guess just putting it more in perspective, we probably should maybe mention this a little bit earlier, but what exactly are like the end products that Pangaea sells? What are the range of clothing there?
I know. We went straight to science. So I mean, what we're probably most known for are our tracksuits, right? So we make sustainable lifestyle basics. So t-shirts, tracksuits, denim. And what we kind of started was we went after this category because it's sort of something that everybody has. It's really accessible and it's things that you own and want to own and that would last. So is the difference between something that would be like a party dress, you wouldn't get a lot of wear out of. So if we're going to make something high quality and sustainable, we want you to want to have it in your wardrobe and want to wear it a lot. And t-shirts, jeans, sweats, all of that is kind of, sneakers. So that's sort of how our categorization works. And now we've moved a little bit more into activewear and accessories, but we're staying, we will do some things that are a little kind of dressier, but it'll be sort of in that range of what we call lifestyle basics. So kind of what are your wardrobe staples, from your sweatpants, your activewear to maybe your fancier trench coat or something like that.
So yeah, I think you have a really great background about how you make fibers from all these different sources. And one source that you mentioned was the sea fiber t-shirt. Mm-hmm. And so for our listeners, Pangaya has worked with a seaweed farm in Iceland to restore the natural ecosystem. So that you told us about the science and how you make these fibers, et cetera. How do partnerships like this help impact the environment? And what are some of the other benefits other than just making a sustainable material?
Yeah, so with sea fiber, we worked with a partner that was already producing that, and we knew that like seaweed and algae has such an amazing potential, but there's still a lot of work to be done on like what percentage of seaweed goes into the because that's blended in it's kind of a lyocell type process, so it's kind of powdered and then put into a solution. So how do we up the percentages, et cetera? And yeah, the idea of basically harvesting from, a responsibly sourced place in Iceland was, first of all, we knew exactly what we were getting. So when you start with, earlier stages of engineering, especially with any biological input, the more stable the input, the easier it is to try to optimize the process, right? So you know exactly what blend it is and its qualities and all that, and then you can engineer around that. The real goal with everything in the seaweed space for me is to start using waste. But this is the hardest part. So, when you have like those seaweed and algae blooms, like in Mexico, there's been the crazy Sargasso blooms that are half coming from pollution and chemical runoff and half coming from climate change. So you have like a duality of issues that are making, seaweed absolutely like take over the beaches of Mexico. And I mean, you're down there, they're carting it away and burning it. And I'm thinking, oh, this is an amazing input. But the issue is more that there's going to be many different strains and many different kinds, plus it's polluted, whatever. So there's just a whole other level of characterization, cleaning, planning around the waste collection. So first you make something with the pristine Iceland single stream, it's just perfect, harvested from perfect waters. That's where you start, so that that, okay, the fiber will work. And then you have to kind of go and then re-engineer from waste. Like, how do we then make it happen from waste? So that's our ultimate goal in that. And so it's this, like the sea fiber that we have now, that's our first foray into, we understand how seaweed can be really valuable, and then also looking at how it can be blended with other things. So again, looking at how do we take the characteristics of the seaweed, and what are the best parts of it, and how do we optimize that inside of a blend?
Can we do a little bit deeper dive into that? Like, what are those characteristics or the properties that the seaweed possesses that make it valuable for this application?
Yeah, well, one of the things is, and this may be not exactly what you're asking, but this is why it's most important to me, is so with something like seaweed or algae, it's like one of the most perfect organisms. I could wax on about algae, but it has, so as an organism, it has cellulose, lipid, and protein all in like a single cell, which is just kind of amazing. So you can literally use every part of it. So for example, the end goal for a lot of our materials is what we call side streaming, where instead of saying, okay, you're going to take one part of it, we're going to take the cellulose and throw away the rest of it, you actually have different supply chains. So with seaweed, you could use the cellulose for fiber, you could use the lipid for plastic, and use the protein for food, right? That's ideal. So then you get so much more value from growing a single organism in terms of input and everything. So that's why one of the main reasons why we're absolutely going after seaweed in that way, because every part of the organism is useful. And it also has, first of all, it's one of the best carbon sinks in terms of plants, because every part of the organism photosynthesizes. So you get a higher level of carbon sinking, and it also doesn't have land requirements. I mean, the ocean that grows in the ocean, right? Or water requirements. So a lot of the things with on land agriculture is the impact of land use and water use. So are you destroying a forest? Are you importing water? Algae, you don't need those things. So those are like really the main reasons. And then the cellulose itself is quite usable, but I'm not sure I'd pull out specific characteristics cellulose is cellulose. It's sort of about where it's coming from. In some ways, it's harder than cotton cellulose because it doesn't come in the perfect kind of fibrous form, but that's about how you manipulate it in solution. So it's really about the whole environmental structure around algae and seaweed and the side streaming pieces of it. So as an organism, it has a lot of value, value for cost, basically, for the impact cost on the earth.
Yeah, awesome. So then I'd like to compare that to like companies who use traditional methods. Like you mentioned this earlier, but they have decades of a head start in like refining their processes, right? So for our listeners, what can material scientists in the sustainable fashion industry do to ultimately like reduce the cost of manufacturing and the challenges that come into play when approaching it from the sustainability perspective?
Yeah, no, that's a great question. And I think the first thing is like some of the best innovations come from like a process in one area of engineering or science that then gets applied to a different thing. So first of all, kind of mastering of the processes of material science, or say synthetic biology, or how things are made or how they grow, right? And then trying to understand how to apply. So think differently. So this idea of this is how fiber has always been made. You can say, well, you can challenge that in a sense of like the fact you can almost in a sense of being naive and saying, oh, you're not in the traditional fashion. So what if we made it like this? And there's a lot of times where there'll be kind of, the solution might seem crazy in the sense of it can't happen fast or cheap enough at the beginning, but that's it's sort of about how that gets applied and scaled. So I think about it a lot with things like with synthetic biology, right? When you're growing, so just, I'm sure your listeners probably know a little bit about this, but the idea that you can basically take DNA from one organism and put it into a microorganism and grow the qualities of something. For example, we did a collaboration with a company called Colorifics, which is growing colors through bacteria. They've done basically taken DNA from naturally occurring pigments and transpose it into these organisms so that when you feed the organisms and they grow and multiply, they create the color itself. So this is better, this is more sustainable than just growing the plant, using all the land, water, energy resources to grow something. You're growing everything, but you might just need the small flower to get the thing. So you're literally just growing the dye. So there's a whole sustainability argument around a lot of synthetic biology for food and materials and everything. But it's also like the infrastructure of the manufacturing can make it slow and expensive, right? So it's about the whole industry needing to kind of grow and transition. So anything that we can start to think about in terms of manifesting those processes and how they fit better into supply chains is a big thing. And then, yeah, I think that's, and then I also think going back to anything that starts with bio-based inputs. So even if you're working in a lab, and you're going to be using the chemicals there, but thinking about how could I replace this chemical with something that's bio-based or naturally occurring or comes from waste, or really thinking about where things come from, even if you're starting with something in a perfect form. So like the analogy that I made with the algae, like we're using something that's perfect, but could it be waste? And that I think has a lot of value in terms of setting up, the new supply chains around returning to the bioeconomy. So anytime you can start to think about how processes get closer to mimicking nature, that's of huge value.
Well, I think that's a great explanation of how we can make change. So now I guess looking at Pangaea, as Chief Innovation Officer, what is your goal for the next 3 to 5 years? And what are the major goals of building upon all these great successful projects and taking it a step further? And I guess finally, how can we as listeners and material enthusiasts follow along with your journey?
Sure. Yeah. So we, as I said, we have a kind of R&D plan that goes out about, to where we want to be in like 8 years, which is not very typical of fashion companies who are working seasonally, quarterly. But I think that 2 of our important kind of near-term goals that we have innovations in place are, so the first one is looking at the world of synthetics. So 60% of garments out there use some form of synthetic and a synthetic blend. So I'm talking about polyester, nylon, et cetera. So we've had a long-term ongoing, like since we were founded, basically a partnership with a company called Kintra Fibers, which is developing the first fully bio-based, fully biodegradable nylon alternative. So it has the same qualities, and we're finally getting close to product. So that's a really exciting breakthrough. And just to be able to kind of have something in that space that that does give a fully, a full alternative that we can, and we also have, a B2B channel inside of our company. So we'll also expand it to sell to other brands. So we hope that is a kind of that's anything that we can do that makes a replacement for things that are traditionally made from petrochemicals is big for us. Yeah, and then I think, in general, the other thing is really honing in on another like alternative forms for animal leathers. So it's an exciting space with mycelium, right? And having, like we did with flower down, leathers that don't involve animal products, or not, we say nothing that involves animal slaughter. We do use a little bit of wool, like, and we're not 100% vegan in that sense, but nothing with slaughter. And so there's lots of leathers that are plant-based, but have a lot of polyurethane in them. And so when people say vegan, you go, you know what, but don't you just mean plastic? There's like it's that funny sort of space where the labeling and the greenwashing, it's like, oh, it's vegan, and people think it's made of plants. You're like, no, it's actually just made of plastic. So vegan, but no plastic is where we're trying to go. So there's some like interesting stuff in that space with mycelium, different plant-based leathers, process tech. So a lot of stuff in that space too. So, but I think in general, we're looking at solutions across the board of what are the major categories of textiles and how do we find the fully plant-based, waste-based alternatives. So like, for example, carbon transformation space, what can we do with excess carbon and carbon sinking, everything in the dye world. Some of our highest, we've complete LCAs on all of our products, and some of the highest impacts are in these secret spaces, dyes, treatments, everything that it's not just thinking about the entire process of the material and not just the physical material itself. So all the things that go into making something. So
I don't know if you're going to have this number off the top of your head, but one thing about sustainable like infrastructure and making these sustainable processes is that we're not as like blessed with all these raw resources, and sometimes the material stream can come and slow down. And that's what you're saying about creating all these different waste streams to help feed into the same product. I guess in 5 years, as you continue to scale and you continue to bring in these waste processes, how much more like material do you think you'll be able to make, like on an order of magnitude? Or do you have any sort of idea on how much better we can be at taking in material and putting out usable?
Yeah, it's not so much that I don't have the numbers at the top of my head, is that there's so many different variables and inputs to that. Like there's no single number. So it could be based on the different kinds of fibers, the different kinds of processes, all that we, so we, we'll be putting out our impact report for 2021 very soon. We got all our LCA data back, or, processing all of that and doing all the calculations, and the complexity of the analysis, like the input data, the analysis data, it's still a pretty new area of science. So even just questioning the methodologies and questioning the data sources, something that's like a primary data source versus something that is a kind of an assumption data source, a secondary data source, that we call that, right? Which is still valid. We're still doing a valid analysis, but it's based on a generalization in some way. And just that complexity so it becomes like an entire report and not a number, if you know what I mean, to say. And then also thinking about, again, priorities, right? So we have our impact and R&D priorities, like, for example, getting rid of petrochemicals, getting rid of conventional animal products, moving towards regenerative agriculture. Those are our principles, but people might have different ones in terms of their own sustainability metrics. So I'm sorry, that's like not the best answer, but it's just, the answer is that it's complex analysis. But one of the things we are feeling hopeful about is that there are a lot of brands that are, well, first of all, there's a lot of brands that are interested in this space, and also there's new legislation which is forcing brands to be interested in this space. And the more people that want these new materials, like, for example, regenerative cotton, we invested very early and basically at the farm level to get regenerative cotton. It takes like at least 3 to 4 years to transition land into something regenerative, and now there's not even enough available. So that's a good sign in the sense that when the demand is there, there's a lot more motivation to make the changes.
And so for our listeners and for us as well who want to follow along with Pangaia's journey, where can we go? Is that Instagram, your website?
Yeah, both of those. And we have something called, we've recently launched Pangaea Lab, which is the part of our business that kind of where we launch what we call first, best, or only. In this, so the products of this is where we're trying out the most complex science, and we usually do a smaller run. It might be more expensive to start, as we're sort of trying out the scaling. So it's like the beta version of things, but in a, instead of thinking about it as a compromise, we want to think of it as like, oh, this is where the early adopters go, like in software and hardware, right? This is where we can get the latest coolest thing. And we plan to actually also launch more scientific content around the products that we have on our website. We have a section around our science and everything, but we'll be kind of going more and more. I'm starting to call it the place where we can nerd out, so we can have a bit looser, have more technical data. We don't shy away from using the words, but this will be the long form paper of what you'll see in our social media as a paragraph. This will be here's the rest of it kind of thing. If you really want to read it. So we're kind of getting that up and running, but there's a whole glossary on our website, and we and then all the series of launches, and then our the impact report will be coming out in a couple of weeks, which will have more data than you'll want.
Yeah, I'm sure our MSE community will be all over that.
Yeah.
But cool. So we covered quite the variety of unique innovations in the fashion industry and at Pingaya, from harvesting wildflowers regeneratively to taking waste from the food industry and turning it into clothing. So we just love for you to kind of wrap up this episode with your final piece of advice for material science students and professionals who are looking to really innovate and disrupt industries where there's kind of been that traditional way of doing things for a long period of time.
Yeah, so I'm going to sort of say something that I kind of already said, but I want to put emphasis on it is anytime you can turn back to natural processes, the biochain, the bioeconomy, you use your technology and innovation to kind of augment and upscale natural processes. It means we can get back to something that is sustainable more easily. So kind of looking at those inputs and, still doing whatever research you need to with what's available in a lab, but thinking more broadly about, can this work in a kind of balanced Earth system, or am I designing way out of it? That would be kind of my biggest piece of advice for anybody, thinking about new lab research.
I love that. Well, thank you so much for joining us today, Amanda. It was an absolute pleasure.
Thank you. Yeah, thanks for having me.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.